can you solve this geometry challenge? Here's the question. Let's start with a semicircle. Now from here, let's draw a tangent segment that is parallel to the diameter of this circle. And from this point, let's draw a segment that is connected to the tip of this tangent segment. Now, this segment divides evenly with this point. Now, this angle measures alpha. Now, the question is, what is the measure of this angle, alpha? You can pause this video if you want to give this problem a try. Now, suppose you pause this video. Now, let's see if you got the correct answer. Alright. Now, given this information, wherein this point divides this white segment evenly, and this tangent segment and the diameter of this circle are parallel, then our goal is to find the measure of this angle, alpha. Now, to answer this kind of question, we will use the important points. And the first important points must be this point, wherein this point divides this white segment evenly. So what we're going to do is from this point, let's connect the endpoint of this diameter. Now at this point, we see a triangle inside our semicircle, wherein the longest side of this triangle must be the diameter of the circle. It follows that this triangle must be a right triangle. Now at this point, we will use the fact that these two segments are equal. So what we're going to do is to draw another right triangle like this. Now, these two right triangles are said to be congruent by leg-leg postulate. So because they are both right triangles, the two legs are congruent. Therefore, these two right triangles are congruent. Now, what do we know in this right triangle? We know that the third side, or the hypotenuse, must be the diameter of the circle, or simply equal to 2 times the radius of the semicircle. Next, since they are congruent, these two right triangles are congruent, the hypotenuse of the other right triangle is also 2r. Now, at this point, we will use another important points in this figure, and here it is. The intersection, or the point of tangency of this tangent segment to the semicircle. Now, if we draw a radius like this, we know this radius is perpendicular to this tangent segment, and this radius measures r. And if we slide this radius like over here, we get a right triangle. And what do we know in this right triangle? We have the hypotenuse of 2r, and one of its leg must be equal to r. And it reminds me of the special right triangle 30-60-90, because in a 30-60-90 right triangle, the hypotenuse is twice the measure of the shorter leg. So it follows that the angle opposite of this small side must be equal to 30 degrees. So this angle right over here must be 30 degrees, and the other angle must be equal to 60 degrees. Alright, next, we are now ready to find the measure of this angle alpha. And what concept do we use? The concept of this parallel segment and this transversal line. So we will use the alternate interior angles. Here it is. Now, this concept tells us that those alternate interior angles must be congruent or equal. So if this is alpha, this angle right over here must be also equal to alpha. So again, if this is alpha, this alternate interior angle is also alpha. And since these two right triangles are congruent, then this angle right over here, we can say that this angle must be also equal to alpha. Now, this angle, we know for sure this measures 30 degrees using 30-60-90 right triangle. So we can say that 2 times alpha must be equal to 30 degrees. And to solve for the measure of angle alpha, let's divide both sides by 2. And 30 degrees divided by 2, this will give us 15 degrees. And that is the measure of angle alpha. Therefore, given this figure, we get that the angle alpha must be equal to 15 degrees. And as always, we are done.